So now I will consider the inverse cosine function. So let f of x be inverse cosine inverse of x, and then the question is find the derivative of this function. Or using other notations we can write y equals inverse cosine x and find the derivative of y. So this expression y equals inverse cosine of x is equivalent to saying that x equals cosine of y. But in order for the inverse cosine to make sense, so we have to put restriction of y. So y is not arbitrary, y should be between 0 and pi. And x as any cosine, so the value of cosine is always between -1 and 1. So it's always important to have in mind the restrictions on x and y. So how to find the derivative of this function? So same thing like we did with the sine, we will look at this equation and we will assume that y equals cosine inverse of x is implicitly given by this equation. Implicitly given by equation x equals cosine y. So it is implicitly given function, and so we will find its derivative using the techniques of implicit differentiation. And the techniques of implicit differentiation, so we will use left-hand side derivative equals right-hand side derivative. This is the main trick or main technique for implicit differentiation. Now the left-hand side is just x, and so the derivative of that is just 1. So left-hand side is just x. So the derivative of the left-hand side is just 1. Now right-hand side is cosine y. And the derivative of the right-hand side is, since y is a function, then right-hand side derivative should be calculated using the chain rule, and that means derivative of cosine is negative sine y, and then it should be multiplied times the derivative of y. Now, since left-hand side derivative equals right-hand side derivative, this means 1 equals this. So, okay, 1 equals the derivative of the right-hand side, which is negative sine y times y prime. And from here we can solve y prime easily. So y prime equals, we need to divide both sides over negative sine y. So it's negative 1 over sine of y. So this is how I typically solve problems regarding implicit differentiation. So the derivative of y is expressed as a formula involving y. However, it's actually better to solve it as a formula involving x. And x equals cosine y. So in order to express it as a formula involving x, we need to express sine y as a formula involving cosine y. So we need to express it with cosine of y, because then we will just replace it with x. Right now it is expressed with sine y. So what do we need? We need to express sine y as cosine y. And for that, we will use the main trigonometric identity. Sine squared of anything, in this case we need y plus cosine squared of anything. In this case we need y equals 1. And from here we can express sine. So sine squared sine squared of y equals 1 minus cosine squared of y. And therefore sine of y equals square root of 1 minus cosine of y. And once again, this square root when we do square root of both sides, so typically square root could be positive or negative. So we need to make sure that we know the sign of this square root. And in fact, since y was between 0 and pi, so we can write it, we can draw a unit circle and see, so y actually covers this is the y, it covers the top half of the circle from 0 to pi, so y is the angle, and when y is between 0 and pi, then sine of this angle is the y coordinate, it's always positive, so greater than or equal to 0. And therefore, in this square root will always be positive, so we don't need to consider negative square root. So sine of y equals square root of 1 minus cosine y, and since cosine y is x, so that is the same as square root of 1 minus cosine squared. And since cosine y is x, so cosine squared y is 1 minus x squared, so we get square root of 1 minus x squared. So sine y equals square root of 1 minus x squared, and therefore, plugging back here, we get y squared equals negative 1 over, and instead of sine y, we plug in this formula, we get square root of 1 minus x squared. So this is the answer. So here is what we got. If f of x equals inverse cosine of x, then the derivative equals negative 1 over square root of 1 minus x squared. Now this derivative is very similar to the derivative of inverse sine, except with inverse sine we didn't have a minus here. So for the inverse sine, the derivative is 1 over square root of 1 minus x squared. For the inverse cosine, the derivative is negative 1 over square root of 1 minus x squared.